Do you remember? Earlier, we used an all-pass filter and polarity flip summed to an original signal to create a filter. Well, we're going to dive deeper in that same concept, and we're going to use phase and polarity flips to create an audio signal splitter that remains totally transparent. What I mean with transparent is if you just overlap two traditional filters, if you sum that with an original signal and you flip the polarity, you don't get a null. It's not exactly the same because the phase shifts don't align. And we're going to do something where we now can split signal in 2 or 3 bands that stays totally the same as the original signal. Wait, but why would anyone care about this crossover frequency of any multiband processor? Well, the thing is, if you have just one processor inserted on a channel, it doesn't matter that much. But as soon as you want to do some dry-wet processing or use this on a sand, well, if there is a phase shift on the multiband processor, the phase shift summed with the original signal will create some filtering. It will create some changes in your sound which are unwanted. So if you want to be able to dial in processors on some bands of the signal and you don't want to alter the dry signal with phase shifts, you need a way to split signals that is respectful of the phase. The great part of that is that now you can apply dynamic processors or any given processor you want to your signal to any band of that signal. I'm going to show you something. I have here a operator playing. I'm going to change the waveform. Operator playing a saw wave. First, I'm going to remove everything. Okay, operator playing a saw wave, right? Well, now let's turn on the high cut. What I did is we have a high cut filter, polarity inverted. This gets summed to the dry signal to create now the opposite, a low pass filter. On another chain, mapped to the same button, the high pass. So here is the same filter at the same settings, but with the polarity flips doing the low pass. So I made a 2-band splitter that is totally transparent. Let's start with 1 band. So this is my mid band. High pass, low pass. This is the starting point, right? This is what is creating the mid part. I put limits because it starts to be messy if the crossing points are getting on top of each other. So for the sake of my use, I limited these to some musical uses. Being here, you see the high cut is starting at 2 kilohertz and the low cut is stopping at 400. So I have like 20 hertz to 400 is like my low end area, and 2K up higher is my top end area, and everything in between is the mid part. This is my mid band. Then the high part, what did I do? For the high part, I'm taking out the low cut filter, letting only the high cut filter turned on. And because I'm flipping the polarity, the highs is what is not removed from the signal. So it's the only part that is not subtracted from the dry signal, hence leaving the highs. For the low part, I did the opposite. I left the high cut out, keeping only the low cut on. Because I'm cutting the lows, there are no lows, and so this is the only part that doesn't get subtracted with the polarity flip.